Good morning, good afternoon, good evening, wherever you may be hailing from. This is the Fedora Podcast, and I'm your host, Eric the IT Guy Hendricks. And on today's 47th episode of our podcast, we're going to be asking a very important question. Have you ever wondered why RISC-V hardware is such a game changer? How does Fedora fit into that journey? And I could think of no one better to answer that question alongside me than Mr. Noah Shalaya. Noah, welcome, sir.
I am excited to be here, and I'm particularly excited to talk about open source instruction set. I think sometimes it's one of those conversations that gets kind of buried beneath the sexy because it isn't for a lot of us day-to-day stuff. But I think it's really important if we're looking with an eye on the future, what's coming down the pipe, as good technology stewards do. We should be aware of what instruction sets are available to us, and as they're becoming available on open source, one of the things that's routinely surprised me, Eric, every time I've had a chance to get hands-on with these things, I find way more software is already ported and already works there because of the very nature of open source. So I'm excited to dig into it and find out what aspects the Fedora ecosystem supports.
Isn't that beautiful? I mean, there's just globally all over the world there are just nerds out there that are like, I use this thing and I'm really excited about this hardware. Let's marry the two, and now look, my thing works on this new hardware. But it is so much more involved in that. I'm really excited today. So let's bring in our guest. Isaac, welcome to the Fedora Podcast. Why don't you introduce yourself?
Hey, good morning, good evening, good afternoon, good whatever it is. Buenos dias, and hey, guten Tag, whatever. Isaac here. I am a humble servant of the RISC-V international community, helping, as part of Linux Foundation, RISC-V get the wheels on the bus and get things moving with regard to building products and encouraging the software ecosystem on board, because at the end of the day, a new architecture isn't of much use unless you actually have a real deep, rich software ecosystem to run upon it. My background is, let's see, pretty varied, not what you'd probably expect. I actually have a degree in Italian and computer studies. In addition, I speak multiple languages. Italian, Spanish, English, some Irish, study Greek and Latin, and I'm currently studying Portuguese just because I want to keep my brain kind of going and I'm interested in it. But that kind of lends itself into languages in general, where if you learn one language and then you learn another language, it's a lot easier to learn a second computer language than it is to learn a real language. And part of the thing that fascinated me when I was in college was actually studying x86, or 8086 as we called it at the time. And this was the Bible that we used, which was, computer architecture by John Hennessy and David Patterson. And David Patterson turns out to be a primogenitor in the lineage for RISC-V, which is really, really cool. And he is equally as important in the RISC-V community with regards to understanding what it is, what an instruction set architecture is, and it's the nitty-gritty. And I always say to people, and this is what fascinated me when I was doing assembly coding in college, was if you go into the Sistine Chapel in Rome and you look up at the creation picture of, you got Adam and you got God with the creation and the fingers, right? Well, it's the space between the two fingers is where the ISA lives and where the magic happens. And fundamentally, all these CPU architectures that are out there, and whichever, like if they're PowerPC, if they're Z, if they're Motorola chips, or if they're x86 or ARM or whatever, they all have a very similar architecture. They're still ALUs, they're still translation buffers, they're still, we'll say, registers for memories, etc. But when you think about when you're doing a new instruction set, well, you're going to have to describe pretty much ad nauseum how the inner workings theoretically should work on this new architecture. And that is kind of the core of how they try to build this new international standard called RISC-V. And RISC-V has been around 15 years this year, which is a long time. And it was a progeny of David Paterson's that Kirsta, who's over at Sci5 now, that's kind of in the lab outside in the college in California, that they kind of started doing RISC-V 15 years ago. And now it's come a long way. So it's not, a lot of people will hear RISC-V that may not be in the loop and may think, oh, what's this new thing? It's like, it's not that new. And these type of plate tectonic shifts happen only once or twice in a kind of a, in your, let's say, working life in some respects, right? And x86 has been the dominating force in the industry, and we owe a debt to x86. I mean, we have to look at what went before us. We've learned about how to do things, how not to do things, and RISC-V is an extendable architecture where we have kind of, it's a community-driven thing where people are building this in collaboration with each other, and you know, how should this behave gets described by sundry parties, and they agree to what the definition should be and the standard should be. But the beauty is that they've learned from prior incarnations that you don't want to paint yourself into a technological corner. And I think with Moore's law coming to a head, with x86 itself, it has run out of headroom where, you know, okay, you got chiplet technology, etc., but it's like it's at its limit. Whereas RISC-V compared to x86, we have this extendable architectural feature built in from the get-go, with the result being that we're going to have extensions down the road that none of us on this call even know what they might be, but they can get baked in to the future descriptions and standards, and this thing will just continue to blossom and grow over time. So I think I jumped into what you're probably going to ask me here, but I'm going to let you ask some questions.
We prefer it to be a discussion, so that's actually great. Can you talk a little bit about choosing an operating system? If somebody's hearing RISC-V and maybe you got them on board just with that, and they're like, hey, I'm interested, I'm bought in, how do I get started? What do you look for when you're trying to pick up an operating system that you're going to have a good time on RISC-V? Does any Linux distro work? Are there ones that work better than others? Are there some that have tools and more packages? What does that look like?
Okay, so this is where I get a chance to use one of my props. So in the beginning,
awesome, by the way,
can you see this?
Yes, yeah, we can.
This is an infamous EV7 Alpha chip. It was the last of the line. This was the best, the greatest piece of silicon in its time. The best. And forgive me, all the Sun Solaris nerds out there, it was the best. However, what's the major difference? The major difference was the software ecosystem. So we had a software portfolio that was like this size, important applications, an operating system or two or three, and applications, a certain finite set of applications that ran upon it. However, compared to Sun Solaris, they had an application portfolio that was like absolutely gigantous, as did Power AIX, as did HPUX. And this goes back to your question, where what you're trying to decide is, if you're a silicon company, you're playing a different game. Your nose is at the coal face. You're trying to design silicon. Okay, the ISA have to conform to the ISA specification. I'm creating silicon in accordance with that. I don't have to pay for the IP. This is fantastic. Traditionally, it cost me an arm and a leg to do that, and no pun intended. And today, you can do it for free. However, when you back out from an end customer perspective, so here I am, like, and I'm a software engineer, I'm a developer somewhere. It's like, why should I care about this newfangled dangle thing? And it's like, well, what do I need? Oh, I need what's the operating system I use? Oh, okay, I'm a great fan of Fedora, or I'm a great fan of RHEL, or I have to mention the competitors here, Ubuntu or SUSE. And, I'm not going anywhere, and I'm not betting the bank without any of those people involved, or whatever your particular view of the world is. And people make decisions in these big shops based on their operating system, their hypervisor, and the application portfolio that runs upon those particular instances. Now, today, where are we with regards to RISC-V? Well, the good news is, and I was originally one of the pole bearers, so to speak, with John Masters and 3 or 4 others. It was a small community in Red Hat where we were the people that were chasing the bus, trying to get everyone to do ARM when nobody wanted to do it. And the challenge that we saw was trying to get people to start playing with it, trying to get Fedora to play with it, trying to get upstream Linux to play with it. And it was a very, very slow and uphill battle of rolling that rock up and getting flattened every so often when it rolled back on top of you. Compared to where we were back then, with regard to the Linux communities and ARM enablement, we are way ahead of the posse this time around. The good news is that upstream Linux has embraced RISC-V wholeheartedly, and all the necessary bits, giblets, etc., are enabled in the compiler space. All the major compilers, debuggers are enabled. Are they optimized? Optimization is a continuous improvement activity. If anyone has done performance benchmarking, they know that, hey, you run a performance benchmark, you find a roadblock, you remove the roadblock, and when you run it again, you found a new roadblock. So the same goes with performance benchmarking or optimization of compiler code and debugger code. It's an ongoing evolutionary experience. So the good news is that the compiler space is there, the debugger space is there, and then when it comes to upstream Linux is there, and then when you come downstream from the upstream Linuxes and you look at the community Linux distributions, the one that shines very brightly is Fedora. The others shine as well. I love all my children the same. The Fedora folks have done a great job, and I will single out what's his name, Bologna, and Richard Jones and Gary Case's team, Wei Fu and company, for all the enablement work that they've done. That traditionally it's yeoman's work, and nobody knows these people exist. But without them, and without the work they do from a silicon enablement perspective to get the boot and runtime services up and running and get the operating system loaded onto a system and start debugging that and making it available, like we've seen with Fedora, where now you can actually go in and there are certain builds where the supported hardware where you've got Star5 Vision 5.2, which is the flagship for Fedora right now in the builds in Koji, where you can actually check out a build and you can build this pretty much out of the box, very straightforward, very easily. You can also load QEMU with Fedora from those builds, which is another win-win. And on top of that, then you've got, what was the other card? There was the Sci-5 P5050, where it works, it's fine. There are some firmware revisions from the vendor in question that you've got to kind of stay on top of. So it's not as out of the box as the other builds, but it's getting there. And then on top of that, you have there's support built into Fedora if you want to kind of roll up your sleeves for Banana Pi and for the Milk 5 boards, etc., where it'll take a little bit more coaxing. Now, if you want to kind of roll up your sleeves further and take a net new card and say, okay, I'm going to work on this and I'm going to work with the community to help it get this kind of enabled and turned into a bona fide citizen within the Fedora build system, of course, you're open to do that. And we encourage people to join the Fedora RISC-V SIG, the working group, and to participate proactively with the Fedora builds and to do some testing and contribute issues to the issue tracker system. If they find something that's missing, if they find something that's not working, this is where the community really comes together. So I'm going to step out of this for a second. Connected, bear with me. there's a great meeting that happens where there's another project run by the Linux Foundation that's called the RISE project, right? And it stands for RISC-V Software Ecosystem Project, where they're focused on working on specific areas of compiler, CI/CD, and other stuff, where they actually create projects and put them up to bid and tender, and people actually bid on them and go off and do the work. The beauty of RISE is that it acts as a neutral third party, where there's a distribution meeting where, for instance, Redbeard, I'm sure everyone here probably knows Brian Harrington, CoreOS fame. So Brian has got his finger in RISC-V enablement as well. Forgot to mention that earlier. And he does a distribution meeting, and it's an open meeting with, you name it, different distributions, SUSE, Ubuntu, RHEL, Fedora, and others. Can't even remember the full list. They come together, and the beauty is you're watching real-time, true community collaboration, where all these individuals are talking about problems they're trying to solve to enable RISC-V, but in the context of community and collaboration, as opposed to, hey, I work for Canonical, or hey, I work for Red Hat, or hey, I work for whoever. And it is a wonderful thing to see, where you've got competing entities in the field of business that actually collaborate so closely and effectively together in a true upstream open source community way of doing things. That for me is like, attending the meeting this morning, I love just seeing these people collaborate, because it's like, wow, this is the proof of the pie in the pudding. Because, you know, I worked for 11 years at Red Hat. I managed the team of engineering partner managers, where we did all the OS enablement in collaboration with Peter Barticelli's team, of course. And we worked with all the partners across the silicon vendors, the hardware vendors, the I/O adapter vendors, etc. And then I extended into the OpenShift and OpenStack side of things, where we were more focused on the cloud side of the equation. And I'm happy to say that both those teams are still there behind, and they're still full of the individuals that I originally collaborated with, and they're a wonderful bunch of people. But there are similar teams across all the distribution vendors that have to do the same kind of yeoman's work of connecting the bits together and making sure that people are doing the work that they need to do to enable a new architecture. And coming back to, of course, this is a Fedora podcast, so I'm going to say, you want an operating system that works? I just told you with the 2 cards that you can take right now, you can get your builds off the Koji build system, and on your way, mate, and do your work.
Yeah, I mean,
That's really awesome. And so during the pre-show, which I still argue we should record just for fun. During the pre-show, you're talking about some of the lessons learned between some of the predecessors for RISC-V, like x86 and ARM, and how I'm hoping I can do this justice, so you can kind of tell us the same, tell our listeners the same story you told us, was how in the early days of ARM, how there would be kind of these behind closed door builds that weren't readily available. But now with RISC-V, that process is different, particularly with Fedora, how you can go out and get these RISC-V builds readily available. Then you can go out to, say, like Sci-Fi and buy a board and start trying the stuff out without having to go behind those closed doors.
So I'm going to go back in the time machine. I was 10 years plus, and somebody's probably going to correct me because I'm going to get this wrong. But if memory serves me right, we were doing pre-builds, and I think it was Arcadia was the name of the release. And it was a separate, complete build of RHEL for ARM. And it was quite laborious because this all had to be maintained separately and built separately. And eventually it trickled into the rest of the ecosystem, including Fedora. But it started as its own little skunkworks project. Whereas this time around with RISC-V enablement, we've started in the real front door of enablement for Red Hat build products, where the foundation for all the Red Hat componentry actually starts with Fedora, and it works its way through the system. Where the beauty is that, and kudos to Red Hat for creating Fedora and supporting it. Someone correct me saying they didn't create it, we created it. Okay, apologies if that's the case. But kudos to Red Hat for supporting the effort, because I use Fedora on one of my systems. I know a lot of people that use Fedora on their systems. And it's great to have an enterprise-like system that you can use to do your activities and not have to pay huge subscription fees for. For instance, one of the things we talked about was the availability of laptops, where, now we have deep computing with the framework laptop, where the Roma laptop supports RISC-V. And guess what? You can actually get Fedora pre-installed on the laptop, as far as I know, which is kind of cool. And it was a long time before we ever got to that stage in the ARM voyage of discovery, let's say. Alibaba, they're members of RISC-V International. I could go down through the litany, such as, hey, NVIDIA's there, Microsoft's there. It's a who of the technology world. But Alibaba in particular, singling them out. I helped establish the umbilical when I was at Red Hat into the engineering division over there in the Ali Cloud folks. And, Alibaba is building RISC-V hardware, which is tremendous. When you start seeing that, there is more interest across the industry as a whole, and more people are doing things earlier than what they were in the ARM cycle. That said, ARM does have what we say on the embedded device side, they've got a huge lead. Everyone's got a mobile phone, I'm sure, and there's a lot of ARM componentry in there, but guess what? I'm sure everyone's also following a famous Android operating system that's actually porting its bits and bobs to run on RISC-V, which is that gives you a sense of the gravitas of RISC-V. It's not just Red Hat, it's not just Fedora, it's not just Ubuntu. It's like when you start adding up these major players together and you start to build and click into a bigger jigsaw picture, you realize, holy cow, how come I didn't know about this thing was coming? It's because you have all these kernel engineers and community people that are doing this Trojan work behind the scenes.
Mm-hmm.
That you don't even know exists. And guess what? Thanks to them, we have this wonderful enablement. Now, the biggest challenge at this point is, and I do have a link I want to send for the audience to. I have a questionnaire for software componentry that is of interest to them, that they want to see on RISC-V, that may be missing on RISC-V, and there's a questionnaire they can fill out that I can actually actively track that and kind of go after those applications. But it's at the end of the day, now we have the foundational level. So we got the ISA, we got the hardware componentry, we have operating systems such as Fedora that are accepting us as a standard build platform to build against, which is superlative. And now the challenge is, okay, so what about application stacks, application workloads that will run on top of the conjunction of all of this componentry together, the OS, the virtualized portion of the equation, and applications that sit above us. So it's really the big challenge now is extending up into the software, the further up the software stack to get those applications on board. But the good news is that all the foundational work has been done. Things are just in optimization states. Is everything perfect? I know that it takes a while to build some of these builds on Koji and Fedora. Guess what? You have to start somewhere. And everyone goes through these pains. And as we mentioned earlier, these type of major silicon changes, they happen very rarely through our life cycle, our work life cycle, perhaps in my case a little bit too often. And I remember Wei Fu coming to us. We had just finished doing ARM, and it was probably around the time we did the pre-builds with the original builds that was separate to RHEL and everything else. And he said, "Oh, we got to do RISC-V." We're going like, "You're killing me. We thought we had the last big platform change of our lives done. Now we got to do it all over again." It's the same team of people. They knew what they were doing. They knew how to solve the problem, getting from x86 over onto ARM, or getting onto, for instance, getting from the PA RISC people over, getting the Alpha people over, getting the PowerPC people over, etc. It's the same circle of friends that have been working these problems for the last 20 years. And this is another platform, but they've learned lessons from the last times that they've done this. And I think we're in for a wonderful ride with RISC-V. And I used to think it was a little bit cocky of our former CEO, Callista Redmond, stating that RISC-V was inevitable. Until I kind of joined the merry band and started marinating it and realized RISC-V isn't just inevitable, it is unavoidable. It's already in the embedded space. Look at NVIDIA. Pull out those Grace Hopper cards. Tell me what you see. Oh, there's an ARM SoC. Yes, but what else is there? Oh, shoot. There's a whole load of ASICs that are RISC-V ASICs. How did they get on there? So RISC-V is already here. We just don't realize it yet. And thanks to the Fedora community, it's definitely here on Fedora and via Koji. And, I think have at, join the RISC-SIG within Fedora, contribute, whatever time you can. This is a community, and the beauty of the open source software is if somebody gives a minute of their time, it's a huge plus. If someone gives an hour of their time, it's a huge plus again. And some people are paid, like I am, to work in the open source realm, which is fantastic. I wish everyone could be just dedicated to open source, and I wish that the confines of open source would spill into the intellectual property of everything around us, such as medicine and everything else. And speaking of open hardware, which was a topic that we kind of kicked around earlier in our pre-call, so RISC-V is not free as in free beer. Although when you go to these conferences, there is free beer, I can assure you. There's always been free beer at these conferences, anyone I've ever attended. However, what is free is the intellectual property side of the equation. And while when you think of open hardware, it's not free hardware, but it's free intellectual property around licensing and patents, etc., that spill into your overall cost of ownership of building a new product. And bigger companies can save probably millions to billions by adopting RISC-V as opposed to existing patented IP type technologies. And people start to pay attention where they can save money. And at some point, yes, from a performance perspective and from all things else considered perspective, we will be neck and neck with the competition or ahead of them, or we'll continue to go tandem with each other. Competition is a wonderful thing. We want competition in the field, and I believe this competition is the thing that actually spurs us on. So having competing technologies in the field, competing ISAs, whether some are free or the open source standards, while others may be proprietary. Again, I tip my hat to Intel, where they certainly have created a tremendous legacy that we have all benefited from, and we can build off of to build a better future that's basically RISC-V taking us there. V as in victory. All right, and I'll play my bagpipes, by the way. That's another one of my crazy little habits. I play bagpipes. I do also sing opera. So just a little crazy. I could do probably assembly code in opera in the key of C.
Oh gosh. So we had a question come in from Noel. He's our producer and also the source for the interview today. So thank you, Noel. No matter how many times I try and shove him back in the closet, he finds ways to contribute to the show.
That is definitely not.
His mic and video are muted, so I can give him a hard time. But he actually sent in a question that I wanted to air. So in regards to RISC-V, are there any efforts to get x86 applications running on top of RISC-V through a translation layer, similar to the way that Apple Silicon has its translation layer?
I can't say it's a great question. It's like, this is a motherhood and apple pie question, where, yes, actually, once upon a time, I worked at Apple when they were $3 a share. And the biggest mistake ever made financially is I didn't invest. But they were also about to go under, so go figure. Apple has changed silicon more times than we've probably had hot dinners, right? And they have it down to a fine art with regard to binary translators and porting tools and assistants, etc. And some applications you can just do a simple recompile. Some applications, depending on the C intrinsic code, may not be so easy, right? In which case it's like, okay, what do we do? What is the tooling we need to provide? And part of my remit is to look at what do we need to get from A to B and help developers port code, etc. across. On the one hand, binary translation is a tool and has vastly improved from the FX32 days, where now we've got so many cores on chips that you can actually dedicate some spare cores to doing translation on the fly, and it's a lot quicker. But there probably will be old applications that nobody knows what the sources, etc., that will fall into hey, you're going to have to use binary translators in a VM, right? But you'll want to optimize your code, and it's up to RISC-V, us as an organization, to actually start building the tooling that is needed and provide it out to the communities, the various communities, developers that are going to use that tooling. So, valid question, Noel. I should slip you some money under the table for it. But part of my proposal for RISC-V software ecosystem kind of ISV program is indeed inclusive of porting tools, porting assistance, porting guides, and binary translators. It's kind of, if anyone's been around long enough doing, going from one ISA to another ISA, they realize that there's a certain set of things that you do need, especially for the more complex code streams.
So
is it accurate? Oh, sorry.
Go ahead. If you had a follow-up,
My follow-up is just, is it accurate to say that these days we write code kind of with the idea of building with different infrastructure or on different instruction sets kind of in mind? And so as long as you have a working compiler, moving from one code instruction to the next is not the lift it maybe used to be. And I say that understanding that I'm not a person that does that kind of thing. So there's a little bit of ignorance I'm leading with here.
I think it's Apple's got similar tooling. Google definitely has similar tooling that allow you to dual compile at the same time. So you can actually then take the code and deploy it on different architectures, right? Which, yes, it's a different mindset. Traditionally, people were stuck on one particular platform and were deliberately designing for, let's say, the parking spaces for their car on that particular platform. And of course, they radically are different when you move from one platform to the next. For instance, reserved space not necessarily always in the same place. And operating systems love reserved space because they can park stuff there and they can use it and they can collaborate, etc.
Okay, so another question coming in. So how do you guys view the difference in vendor-supported software with RISC-V compared to other ecosystems, such as ARM?
And that's from Empathy Monster. There's a great name. My mind to your mind, Empathy. I would say the real ecosystem competition for RISC-V, and some people won't like this answer, is you look at the raft of applications, the depth, the width of the ecosystem in x86 from an enterprise compute perspective, that is going to be an absolute humongous opportunity for getting applications running over on RISC-V. Not that we need all of them, we definitely need a critical mass. ARM does not have that today. And that said, x86 has had, what is it, a 40-year start. So it's, they've had pretty much a decent head start on that. And I think between containers and virtualization and various tooling, we're going to see a different set. The necessary ones will be coming over. And like the creme de la creme will be once we start seeing the major high-end database vendors starting to adopt and deploy on the platform. We're still not there. I would be lying and disingenuous to say we are, but everybody's moving in the right direction and we're heading in the right direction.
How do people?
Go ahead.
I was just going to say, can you talk a little bit about what people that are excited about this, maybe where do they get started? And then if they're a little bit more advanced, how can maybe they contribute back?
Okay, so if we do have compiler folks out there and debugger folks, that moonlight in that area, so there's definitely work to be had around optimizations, and your assistance would be appreciated there. We certainly, I think across all the various open source communities, we need better tooling with regards to the CI/CD mechanisms that we're putting in place in these various projects. And we also need to figure out how can we actually connect all of these projects together so that when it comes to kind of a platform effort, you get better contiguous kind of CI/CD going as opposed to just stovepipe CI/CDs. And I will say there are probably quite a few instances where there isn't necessarily a 2025 CI/CD mechanism in place, right? We're getting there. That's the main thing. So that's one set of communities. On the OS community side, if you are involved in the upstream stuff, that would be super. There will be opportunity, for instance, once the driver vendors start adopting RISC-V, and some of them probably already have, just like NVIDIA, have RISC-V real estate on their cards. But those drivers are going to need to be supported upstream and then backported into the various distributions. If anyone's familiar with the term in-box drivers, you'll know that, for instance, Red Hat, and I think it goes for most of the distributions, if the driver's not an in-box driver, then you're kind of in a situation where you can't get certified very easily. So any componentry that's landed on the motherboard has to have a driver that's in-boxed, hence it's upstreamed, and it's also backported and maintained. So there is opportunity from a maintainer perspective. So if you're a young fighting fit kind of techie that wants to see how I can get stuck into this equation, I think upstream Linux enablement, driver enablement, the backporting, the maintenance, there are wonderful areas such as InfiniBand, FPGAs, etc. There's tons of opportunity in the open source world. And I think I've just gone off topic.
No, we're talking RISC-V and hardware. You're right on topic.
I just meandering here.
Well, no, you're helping people develop a breadth of what they can do, how they can get involved, and kind of where all of this stuff is at. So I think that's absolutely fantastic. If anybody else has questions, now is the time to fire them off. Eric, what are your thoughts?
Yeah, in fact, JScar asks, is there any other hardware you would suggest for home lab folks who want to get started working with RISC-V? I know we've mentioned Framework and we kind of mentioned Sci-Fi in passing. Are those kind of the top two, or do you have others in mind?
Oh no, we got a list of boards. I mean, I think we touched on the Milk 5 boards and the banana pies, and there's an incarnation of Raspberry Pi that actually has an ARM chip and a RISC-V chip on it, So if you really want to become bilingual, you could have fun with that Raspberry Pi incarnation. There's a slew of other cards. I don't have them off the top of my head that we haven't listed on the RISC-V.org website that we're continuing to work with. I will also say that we have, and this may actually perk somebody's ears up, we have a boards program within RISC-V. And I would say if you want to publish on the chat my email address, isaac@riscv.org, please do. And anyone can reach out to me. We have the ability to get specific boards out to people that they can actually play with. But the intention is you're going to do something meaningful and useful with the board, as opposed to you're going to have, like Isaac has a key ring here that he does nothing with other than show it off. We want you to do something meaningful with it. So that would be a golden opportunity for you to participate in the RISC-V kind of board enablement spring up process. We are going to have some sort of a certification down the road as well, where that's being worked on. And once the tooling is in place for that, of course, people will be welcome to take that and kick the tires with the tooling as well, but we're not quite there yet.
Love it. So we've addressed all the questions in the chat. So I want, as we kind of wrap up our time together, Isaac, I just wanted to ask, were there any closing thoughts or any calls to action you'd like to share with our audience?
Just remember the two fingers in the Sistine Chapel and the space in two of them. That's where the magic happens. And you folks are in the magic space. And the people that are above you and the people that are below you don't even know you exist. And we definitely need to shine more light on that. And that's been very honest. It's like the secret of the high-tech universe. And it's like people, they look at all this AI stuff. Oh, I'm AI this and I'm AI that. And it's like, guess what? There's silicon. Guess what? There's the space between the two fingers in every single one of these instances. Can't get away from it. So, we live in a very accelerated pace from a development perspective. I would also say don't be afraid of change, embrace the change, because the change is going to get even more rapid. I used to think 10, 15 years ago it was moving really quickly, and now it's really moving even faster. So don't be afraid of change. Embrace it, retool, rekit, and it is 2025, and the operating system is as important, if not more so, than it ever was, which is absolutely brilliant, because 25 years ago, people would have said, yeah, you won't even need operating systems when you get there. And it's like, no, you will, and you still need silicon. So you're at the core of the high-tech universe, and no matter what they do, they need you.
That's awesome. And I think you kind of captured the essence behind why the Fedora podcast exists, trying to grab some of those folks that exist in that blank space. And some of them unwillingly have been drugged on the show and interviewed, but we always enjoy bringing people in and asking, what are you working on? How are you Fedora? How do you Fedora? And just kind of sharing some of the amazing things that are going on behind the scenes. Noah, how about you? Any closing thoughts, sir?
My closing thoughts are, I'm thankful for the work that you're doing in this space. I'm thankful that you are doing, and you can hear it in your language and the way that you're passionate and excited about it is you're thankful that the rest of the world has finally caught up to where you've been for decades before the rest of us caught up to you. So thanks for the patience with the rest of us as you were trudging the path, and as we would say, you're the bridge builder, right? You fell into all of the holes first and then drug, plywood, whatever else across it so that the next person that came across has an easier time. So thanks for doing that.
I've got a big body. I can fill the hole on my own. You could just walk over me. And I see some people on the call here, such as David Duncan. If I had to shine a spotlight, that man is a living legend. So, thank you, everybody. It's a community. It's not about one individual. It's a community. And I was looking back at my life, and we're human beings. We need to be, we're wired to be part of a community, and that whole phrase, no person is an island, we're not. The hardest thing for me is to work from home. I prefer to be in an office, and I love being part of a community. I love being part of the Fedora community, the Linux community, the RISC-V community. It's all about the people, and we can all do this together, and we can change the world. We are changing the world.
Love hearing that, and that's a message that I really appreciate, and I'm sure a lot of our listeners appreciate as well. So thank you very much, Isaac, for what you're doing and for spending an hour to hang out with us and kind of answer some questions about RISC-V. Really appreciate it.
Hey, it was my privilege. Thank you, folks. Thank you very much for having me. Take care.
This has been Isaac with RISC-V. Really appreciate him coming on and joining us as we kind of talk about open hardware. Open source has been a passion of mine for a couple of decades now, and hardware gets left out a lot of times. So really appreciate Isaac coming on and chatting. We'll be jumping on. We'll be moving on to our next topic here in 2 weeks. We'll be live, same Fedora channel, same Fedora time. Doesn't work as well as Batman, but I tried it. We'll be bringing Peter Boyd back on the show to talk about some of the updates and some exciting things happening around the Fedora server working group. So if you're a sysadmin and just can't get enough talking about IT operations, definitely don't miss Peter Boyd. Noah, you do this thing on Tuesday nights. Do you want to tell us a little bit about what to expect?
I do. We're getting ready to fire off another riveting episode of Ask Noah. It kicks off every Tuesday at 6 p.m. Central at asknoahshow.com.
Awesome. You're like episode 9,922 or something by now, I think.
We're gonna hit 500 here pretty soon. Here's the thing, you know what? Like everything else, what I would tell you is like it kind of blows me away. When I'm deeply honored that I've had the opportunity over the years to earn people's ears and that they think I might say something they might want to hear. So I never take that for granted. But what I would tell you is I think now more than ever, there is an important role to be filled to draw attention to some of the stuff that's happening in our space, in our community. And I think we're at a crossroads of sorts insofar as the rest of the world now expects technology to be delivered via apps on, whatever smart glowing thing you have in front of you. And microservices, open source, Linux, all of those things are the tools that are used to build what is now becoming the demand of us in the technical space. So I don't know. It's like all the things have aligned all at one time for open source to win, and it's an exciting time to be able to talk about it. So I'm deeply privileged and humbled and honored that I have the opportunity to do that every Tuesday night.
I love that. And I've been on the Ask Noah show a few times as a guest, a few times as a caller, and always appreciate the conversation and always appreciate the observations and the community. So Ask Noah show coming up here in a couple of hours. You can catch it live out at asknoahshow.com. And I think I'm going to be doing some live ops again this week over on my YouTube channel. And I'll be looking at maybe doing some Ansible playbooks around spinning up Owncast, because we're getting ready to move off of some of the podcast infrastructure that we're using and move to something more open source. So thinking about, what if we had an Ansible playbook that we just kick off before the show that spins up an Owncast box on like DigitalOcean or Linode or something and spins up Owncast, and then it's just ready to go. So might be playing with that live. Also looking at doing a IT career perspective on the big show, on the IT Guy show. So definitely head over to my YouTube channel as well. There's just so much Linux content, so little time. And Isaac, I see you're ready to play us a tune. I kind of wish that we had like credits that we could roll, but as it stands, you should go ahead and play something. I love it. I wish we had credits or fade to black. That'd been even better. All right, everyone. Thank you all for joining us. Really appreciate it, and we'll see you again.